This section is all about adding rational numbers, in particular rational numbers in fraction form. So let's start off with something that's fairly straightforward, fairly easy, and something we can diagram. Something like 3/8 plus 1/8. It's pretty easy to diagram what's going on here. You can think of a circle cut into 8 pieces. So you're starting off with 3/8. So you have one of those pieces filled in, 2 filled in, 3 filled in, and you're adding one more. And you can think of that as now you've got 4 of the 8 pieces filled in. But equally, it's very easy to look at the diagram and see what that reduces to. It reduces to half the circle, and 4/8 is certainly easy to reduce to a half. So that's the best case scenario where the denominators are the same. Now, the numerator and the denominator really do have a meaning. So the numerator you can think of as the number of pieces. The denominator is the size of those pieces. We use a variation of denominator when we talk about the denomination of money that we're using. So if you're talking about the denomination of coins, it's whether it's quarters you're using or dimes or nickels or pennies. And so if the denominator is the same, very easy to add because you're just adding up the numerators, the number of pieces. Now, when the denominators are a little different, we can still diagram this, but it starts to get a little bit more complicated. So let's take a look at the next example, which is 2/5 plus a half. So fairly straightforward to diagram 2/5. We have a rectangle there, and we can diagram in 2 of the 5 pieces. And what do we do to get a sense of a half here? Well, one thing we can do is we've divided this rectangle into 5 vertical pieces. We can now think of dividing it also into 2 horizontal pieces. So if we draw a line across the middle there, right away you can see that you've turned the 2/5 into 4/10, right? Because now you have 10 pieces, and so you've got an equivalent fraction. 2/5 has become 4/10, and half of those 10 pieces is obviously 5 pieces, so we need to shade in 5 more pieces. So there's 1, 2, 3, 4, 5 pieces shaded in. And so what do we end up with? You end up with 9 pieces, and each piece is a 1/10, so we end up with 9/10. But we're not going to want to draw a diagram every time. So how are we going to do this in a more straightforward way without having to resort to diagrams? So let's think about where did the 4/10 come from, because really we got the 9/10 by saying it was 4/10 plus 5/10. So we created equivalent fractions. We went from 2/5 to 4/10. We went from a half to 5/10, and then it was a straightforward addition to get 9/10. So one way to think about how we got those equivalent fractions is we took the original 2/5 and we multiplied it by 2/2. We took the half and we multiplied it by 5/5. So you can see here both denominators are 10, and the numerator on the left is 4, the numerator on the right is 5. So why did we multiply by 2/2? Well, you can think of the denominator on the right, 2 being the key. So we knew that we had to multiply the left-hand fraction by 2/2. And similarly, the denominator on the left, the 2/5, so the denominator was 5, that was the key to understanding what to do with the fraction on the right. We needed to multiply it by 5/5. So this method of taking the kind of opposite denominator will always work. It just won't always lead to the most efficient solution. So let's take a look at an example where the numbers are slightly bigger. Let's say we have 5/12 plus 2/15. So we could just say, well, all right, the denominator on the right is 15. Let's take 15/15 as our multiple to create an equivalent fraction using 5/12. And let's take 12/12 and use that as our multiple to create an equivalent fraction for 2/15. The denominators are clearly both the same, 15 times 12, which is 180. And what do we get in the numerators? So the numerators, 15 times 5 is 75, and 2 times 12 is 24. If you add those two numerators together, you get 99 over 180. Now, clearly, both 99 and 180 have a common factor, a factor of 9. So you can rewrite the 99 as 11 times 9, and you can rewrite the 180 as 20 times 9. And so that 9 over 9 is a factor of 1. We can take that out, and we're left with 11 over 20. So what would be the other way to do this? The other way to do this, you have to do a little bit of work first. You have to think to yourself, well, what is the greatest common factor of those two denominators, 12 and 15? So the greatest common factor of 12 and 15 is 3, which means that I can write 12 as 3 times something, 3 times 4, and I can write 15 as 3 times something, 3 times 5 in this case. So if I want, I can write the two original fractions in a slightly different way. Instead of writing it as 5 over 12, I can write it as 5 over 3 times 4. And instead of writing the 15, or the 2 15ths as 2 over 15, I can write it as 2 over 3 times 5. So now, at this point, to create the equivalent fractions that are going to allow me to add these two, I just simply look at the denominator on the left and I ask, what's it missing that the denominator on the right has? So it doesn't seem to have a factor of 5. So that's what I'm going to multiply the top and bottom by. And that will create a denominator of 5 times 3 times 4, which is 60. And I look at the denominator on the right and I say, well, what's it missing that the one on the left has? So it's got a 3 and a 5, but it's missing a 4. So I need to multiply top and bottom by 4. And I get an equivalent fraction. So 5 times 5, the numerator on the left becomes 25. And 2 times 4, the numerator on the right becomes 8 over 60. So the denominators are the same. It's easy to add these, and I get 33 over 60. Now, this method, you may be thinking, well, it's a lot more work. The advantage is it keeps the numbers smaller. It doesn't mean you're not going to have to reduce it in the end, because you can see 33 over 60 still has to be reduced, right? Both the 33 and the 60 have a common factor of 3. If you take that 3 out, you end up with 11 over 20, which is the same result we got when we did it the other way. So there really is nothing wrong with doing the straightforward method. As I said, it'll always work. It requires a little less thinking. It just means the numbers are going to be a little bit bigger. Now, there will be times when you do want to invest just a little bit more effort and not simply launch into looking at the two denominators and creating a common denominator by multiplying the two of them. And the most obvious example is when one denominator is a multiple of the other denominator. So for this example, 2/5 plus 7/20, if we multiply the two denominators, we get a denominator of 100, and we'll see what that looks like. We can do that example in a second. But there is a much smaller common denominator, and the lowest common denominator is just simply 20. So we only really have to work with the fraction on the left. We have to multiply the top and bottom there by 4. So we multiply that by 4 over 4, and that creates an equivalent fraction with a denominator of 20 and a numerator of 8. So then when we add those together, 8 plus 7 gives us 15. We still have to reduce this, right? Both 15 and 20 have factors of 5. So this is 3 times 5 on the top and 4 times 5 on the bottom. The 5 over 5 is just 1, and that leaves us with 3/4. So what would this have looked like if we hadn't bothered to think about it for a second? If we had 2/5 and 7/20, and we just launched into trying to create a common denominator by multiplying the two denominators. Well, on the left, we would multiply this by 20 over 20, and on the right by 5 over 5, and that would create our denominator of 100 in both cases. 20 times 2 is 40, 7 times 5 is 35, and that leads us to 75 over 100. Again, we have to reduce it. And pretty easy to reduce that one. 75 over 100 is obviously 3/4, same thing. So as I said, you can always do this method, but sometimes the intermediate steps might have numbers that are a little bit bigger. Now, there is one topic in this section that we definitely need to spend a little bit of time on, and that's mixed numbers. So you will see mixed numbers a lot, but I would suggest that you probably don't really want to work in mixed numbers. They are not very convenient, not very easy to work in, but they pop up quite frequently, and let's take a look at an example. So 1 and 3/4, what does this really mean? It means 1 plus 3/4, so we can convert that to 4 over 4 plus 3 over 4, and we end up with 7 over 4. Now, you may have learned terms like proper and improper fractions, and the difference is an improper fraction has a numerator that's bigger than the denominator. There's nothing improper about this, and quite frankly, the terms improper and proper fractions don't get used very much the further you go in math. To distinguish between what we started with, a mixed number, and what we ended up with, 7 over 4, we usually use the term common fraction. So common fractions, 7 over 4 being a common fraction, they're much more useful and much easier to work with. And usually if you have to work with mixed numbers, the first thing you do is you convert it to a common fraction. So let's do that for another one, 3 2/5. So again, what does 3 2/5 really mean? It's 3 plus 2/5. So now I have to create an equivalent fraction for 3 using a denominator of 5. So that's 15 over 5. And then I can add it to the 2/5 to get 17 over 5. So these two common fractions are really much easier to work with. And if I have to add these two mixed numbers, 1 3/4 plus 3 2/5, I would suggest that the first thing you want to do is to convert them into common fractions. Well, we've already got the two conversions there. This is just 7 over 4 and 17 over 5. 4 and 5 don't have any common factors, and so the lowest common denominator really is just going to be the product of them. So if I multiply the fraction on the left by 5 over 5 and the one on the right by 4 over 4, I end up with denominators of 20. On the left I have 35. For my numerator, on the right I have 68. When I add those two together, I get 103 over 20. And quite frankly, that is fine. That is perfectly acceptable the way it is. But if you are required to write the answer as a mixed number, you've got to convert this back into a mixed number. So how do you do that? Well, you have to ask yourself, what is the largest multiple of the denominator, in this case 20, less than the numerator? So the largest multiple of 20 that's less than 103 is 100. So I can rewrite this as 100 over 20 plus 3 over 20. And 100 over 20 is just 5. And so I end up with 5 and 3/20. So 103 over 20 is the same as 5 and 3/20. But I would argue that 103 over 20 is actually much easier to work with. The only reason to put it into mixed number form is if you are somehow required to do that. Now, there is another approach that some people try to take with mixed numbers, and that is to add the whole number parts. So you can think of 1 3/4 as 1 plus 3/4, and if you're adding that to 3 2/5, you can say, well, that's plus 3 plus 2/5. So now I can add the whole number parts, the 1 and the 3, and I can say that's 4. I still have to add 3/4 and 2/5. Now, 3/4, I can say, well, 3/4 is just 15 over 20. If you do this method, you're going to end up with the same common denominator as we had in the previous calculation. 2/5 is 8 over 20. And so I end up with 4 plus 23 over 20. Now, that's kind of useless in that way it is there. It's not a mixed number because you don't write mixed numbers with a whole number part and then a so-called improper fraction. All right, the standard form of a mixed number guarantees that the fractional part is a so-called proper fraction where the numerator is less than the denominator. So now we have to do a little bit more work, and we have to say, well, this is really 4 plus 1 plus 3/20, and that finally gets us to 5 3/20. So, there may be a few examples where it's easy to do this. If you have mixed numbers where the two fractions don't add up to something over 1, that certainly helps. If you have mixed numbers where the two fractions have the same denominator, that would make things particularly easy. But for the most part, I would suggest that you really want to convert your mixed numbers into common fractions so that you can deal with them. Certainly that's going to be the case when we get to multiplying and dividing. You're never going to want to just deal with the mixed numbers without converting them first.